Alright, so hopefully you took a stab at the problem or the project. If you got stuck, no worries. I'll show you step by step how to solve this project problem. So go to File, New Project, and we'll name this BP. PSpice Analog or Mixed AD is fine. And actually, I might name it LED Organ, just one name. And I think that's fine. Now browse to a folder and create a new one called LED Organ. Okay. Select folder, very good. Make sure you have no spaces in your project name or your design name. Choose PSpice Analog or Mixed AD, click OK. That'll create a blank project. Now I'm going to go as fast as I can here. So it'll just be a lot of me just clicking around, but you'll get to see what's up. Quick little tidbit here. So if you want, you can go to Options, Schematic Page Properties, and change the paper size to something larger like B. And then that gives you more room to play with. All right. So save that. And actually, I'm going to name this schematic LED Organ as well. So we'll rename it to LED Organ. And that looks good. So let's get started here with this drawing. So I'm going to hit P on my keyboard, place some resistors, rotate those, and take a little while for them to show up. So let's see, where do I want my resistors? According to the schematic that you should have in your resources, these resistors would be placed in the following various locations. Let's see here. Where do I want R5 to be? Not sure, but I'll probably put this right around here. This would be under a second op amp. And then I'll put one here, one around here. This would be another resistor, and then one over here. Let's see now. And actually, I'll move this R5 over here and rotate that. I wonder if there's anything else I missed. R6 I'll probably put over here. And I'm doing this just to copy the schematic. These don't have to be the exact same numbers. R7 I'll put over here actually. Right around here. R13, well, I don't think I see an R13, but I'm not going to mess with that just yet. So what I'll do is hit P and do a POT. This will be our first time working with a potentiometer. So we'll just rotate that and place it right around here somewhere. And place another potentiometer over here. Now it may look sort of messy or haphazard, but if you really take a look at the circuit, this is how I'm building it. Now let's see. I'm going to change the resistor values just so I don't confuse myself. So 100K. I like to make sure sometimes change my values before I move on to the next type of part, because I easily forget to change one or two resistor values once I add some other components, and then that gets me frustrated. So I'll make this 560 kilo ohms. Now for this potentiometer, you may not have used it before. What happens is the top of the potentiometer gets its maximum voltage, if you will. This is the resistance. And this is the resistance expected here. Let's name it 20K. And then the set will be to 120. Now for this potentiometer, there's a resistor right along here. I don't know, I'll leave it at 1K. There's also a resistor here, so I'm going to place a resistor right here. And that'll be 680 ohms. Let's see what else we've got. This potentiometer over here will be pretty much a copy of this. So set this to 20K. And then set the set parameter to 120. Or well, 120. Next, there's the 1 kilo ohm resistor over here that is in line with the potentiometer. And then this resistor here also needs to be 680, similar to this resistor. See if there's anything else I might be missing. I'll change this 1K to 560 kilo ohms. And then this resistor up here, I'll make it 39 kilo ohms. I'll also give this resistor a 39 kilo ohm value. Alright, so let's place some capacitors. So I'm going to hit P on the keyboard, get the capacitor from the analog library, place one there, place another capacitor over here. There's one that runs along here and also under this resistor. Let's see what else we've got. There's one that goes along this potentiometer. And then there's another that goes along in series with this resistor, more or less. Then place a capacitor under this resistor. We already have this capacitor over here. I'm looking back and forth between the schematic, which is why I'm pausing every so often. Alright, so I think that will be all of our capacitors. Now to change the values. So starting from the right, make that 2200 nanofarad. Okay. Change this capacitor over here to, actually maybe that's the wrong one. I'll put this capacitor over here now, and this will be the 10 nanofarad capacitor. C7, well not C7, but the C4 here. I'll make it into make this into a 10 nanofarad capacitor, and then 560K I'll bring over here. Let's see, what are the other capacitor values we want? So 2.2 nanofarad for this capacitor. Now I could just as well give this something like a 2200 picofarad capacitor value, but that's just to show you that both of these types work. However, standard practice is to go with the unit or the value that doesn't need any decimal points, because it's easy for the decimal places to get lost. I don't know why I wired that. That's just out of habit, but it's fine. I'm going to continue changing these capacitor values now. So we have a 2.2 microfarad capacitor, and then a 2.2 nanofarad capacitor. This capacitor over here will make it 4.7 microfarad. And this one will be 100 nanofarad. Alright, and I think that's pretty much what we're looking for. The last sets of things we'd want for the main part of the schematic is the MC33071 chip /ON, and that's at the ON op-amp library. So hit enter on your keyboard and then place it right around here-ish. And there's that. Where else do we want to place this? Well, actually, that's the only instance of this operational amplifier. So I'm going to hit escape. And now the other amplifier that we want is the MC33272/ON amplifier. And we'll place this right in line with the capacitor here. So that'll be U2A. I want to place the second instance of this operational amplifier here. So that'll be U2B. And then the third instance, I will actually place right around here to finish off the op amps for the bandpass filter. Make sure you save your project. Let's see now. What else do we need? What else? Yes, power and an input signal. So what you do is hit P on your keyboard to go into part place mode. Let's go to VAC, input signal. Hit P again, go with VDC because we need to power our operational amplifiers. And I would do a VEE or VDC for something else, but actually I'll show you a little trick. Alright, hit F on your keyboard, and what does that pull up? That pulls up what would normally be the power, the place power option. So you can keep that in mind. Go with the VCC circle, and then name the first one AC input. Enter, place it right here. That'll be for AC input. Place another one here called VCC. I'm going to rename it, and then this will be VEE for the ground or negative voltage. Hit G on your keyboard and choose the 0 cap sim that comes up here. Wow, okay, so I botched that connection real good. Now ground to ground is fine. That's actually a valid connection, but I don't like how it looks. So all right. Okay, so what I'm doing here is I'm connecting these nodes to this net so that if I put these power pins anywhere else, that part of the circuit automatically gets connected to the power here. So we'll call that VCC. This will be VEE. Double click here, and then you've got 12 volts DC. The amplitude for this thing, we'll call it 5 volts AC. Save your project. And then I think I'm missing something here. What am I possibly missing? Oh, okay, so I'm going to drag this operational amplifier over here a bit. And let's see. I like the alignments to be, pretty much the same. So actually I'm going to drag this over here. Drag this over. Let's see. It's a little tricky. Let's see now. Little tricky. We have the op amp on the output. There's a top op amp and then there's a bottom op amp. So U2A would need to be around back this way. And then this operational amplifier would need to be, well, actually not this one. We'll put this over here. This other one here needs to be right around here. Okay, so I'll drag these back a bit, just so that they're even. And I'll also drag these up. Well, actually, no, those are fine there. Okay, I think we have what we need to do the wiring for the circuit. So I'll see you in the next video.